Hello everyone, in today's lecture we will discuss about the differentiation of product and quotient of two functions. So let's start the video. So here we are we will discuss in this section we will learn the formulae which enable us to differentiate the functions that is formed by product of two functions and quotient of two functions. Let us see what are the formulae. If we have two functions fx is equals to x and another function gx is equals to x square, then one can think that the differentiation of first function f dash x is 1 by power rule, and differentiation of another function again by power rule, it is 2x. Okay, so if we multiply them f and g, we will get x into x square, that will give x cube. Now the differentiation of f into g means f into g prime will be 3x square, like this. Okay, now check again. We have already find f prime x, that is 1. We have already find g prime x, that is 2x. Just multiply them. So if we multiply them, f prime into g prime, we will get 1 into 2x, that is 2x. So we can easily find that both the values 3x square not equal 2x, means both the values are not equal. Okay, so we move to the product rule. Let us see what is the product rule. If there is if there are two functions like f and g and both are differentiable, then the product rule says f into g, the differentiation of f into g will give, this is first function, this is second function. So first function differentiation of second function plus second function differentiation of first function. Okay, so this is the product rule. It is defined here. See, this is first function, we will consider first function. This is second function. So what rule says? First function differentiate the second one. Now plus stop the second one, differentiate the first function. So it is very easy. Let us see some example. Let us see one example, that is differentiation ddx of x into x square. Okay, so we will verify the above result which we have shown in this slide. Okay, so let us see, this is first function, this is second function. Let us go with this formula. So the first function we will differentiate the second one plus stop the second function and differentiate the first function. So what it will give? It will be x there into differentiation of x square will be 2x plus x square will be there. Differentiation of x, you know, that is 1. Okay, now when we multiply them, it will give 2x square plus x square into 1 will give x square, that is 3x square. Okay, now if we go through the conventional rule, that is x into x square, that is differentiation of x cube. So we will get by power rule, that is 3x square. So hence it is verified, means the differentiation of x cube gives 3x square, and by product rule we also find 3x square. Hence, the result verified. So we move to another example how to do differentiation of product of different functions. See, in this example, the first function is x, the second function is e to the power x. Now we have to find the first derivative. Let us start with the formula, that is differentiation of, this is first function, this is second function. We go through the rule. What is the rule? D over dx of f into g means first function differentiate the second one plus second function differentiate the first one. Now, according to the rule, what to do? Stop first function, differentiate the second one plus stop the second function, differentiate the first one. So what you will get? X, you already know the differentiation of e to the power x is e to the power x plus e to the power x. Differentiation of x is 1. Hence, take the e to the power x common. E to the power x common. Here x will be there and here 1 will be there. So x plus 1. So this is the final answer. Okay. Now in the second question it says find the nth derivative, that is f nth time differentiation with respect to x. Okay. So let us try. Here we have done first time differentiation of the function. Now again we try second time differentiation of the same function. So we have already differentiated it. It gives x plus 1 times e to the power x. Now again consider this first function, this is second function, and again apply the same formula. What we will get? So stop the first function, that is x plus 1, and differentiate the second function, that is e to the power x, plus stop the second function, differentiate the first function. So what we will get? We will get x plus 1 into differentiation of e to the power x will be e to the power x plus e to the power x. Now differentiation of x will be 1 plus differentiation of 1 will be 0. So take e to the power x common. What we will get? Here we will get x plus 1. Here we will get 1. So the final answer is x plus 2 e to the power x. Just observe that when we differentiated one time, we will get we got x plus 1 e to the power x. When we differentiated two times, we got x plus 2 e to the power x. So if we go to the same rule, we will differentiate again. So f triple dash or f triple prime x we will get. You can check that we will get x plus 3 e to the power x. So in the same manner, we will find f nth derivative of x, that is x plus n e to the power x. Okay. So this is how we have to find the differentiation up to nth derivative. Okay. Now we move to quotient rule. So it says if we have two functions which are in divide form, say this is first function, this is second function, then the rule says the differentiation of f upon g equal to stop first function, differentiate second function, minus stop second function, differentiate first function, and whole divide square of first function. Fine. So let us see some example. In this example, this is first function, this is second function. According to rule, we will write first function differentiation of second function minus second function differentiation of first function whole upon x cube plus 6 whole square. Okay, now simply differentiate it. We will get x cube plus 6. The differentiation of x square will be 2x. The differentiation of x will be 1. Another part will be 0 minus the x square plus x minus 2. The differentiation of x cube will be 3x square. The differentiation of 6 will be 0 because it is constant. Okay, whole upon it is x cube plus 6 whole square. Now further we will multiply this. So after multiplication we will get 2x to the power 4. When we multiply this with this, plus x cube plus 6 to the 12x plus 6 minus 3x to the power 4 minus 3x cube plus 6x square. Okay, whole upon x cube plus 6 whole square. Further, after simplification, we will get 2x to the power 4 minus 3x to the power 4, that is minus x to the power 4. Further, x cube minus 3x cube, that is minus 2x cube. Then 6x square. Then we will get 12x. Okay. Then we will have plus 6. Is it fine? 6x to square, 12x, that is 12x. Okay. Then plus 6. Now whole upon x cube plus 6 whole square. Fine. So this is the final answer, and this is how we have to differentiate. Further, we move to another differentiation, that is given that e to the power x upon 1 plus x square. So just applying the quotient rule, d over dx of e to the power x upon 1 plus x square. This is first function, this is second function. So first function, differentiation of e to the power x minus second function, differentiation of 1 plus x square whole upon 1 plus x square whole square. Okay, so it will give 1 plus x square e to the power x minus e to the power x. Differentiation of 1 will be 0. Differentiation of x square will be 2x whole upon 1 plus x square square. Further, e to the power x will be common out from this place and this place. So it will return 1 plus x square minus 2x whole upon 1 plus x square whole square. Further, you can see, observe that this is a square plus b square minus 2ab, so e to the power x. This is a minus b whole square, means x minus 1 whole square whole upon 1 plus x square square. So this is how you have to differentiate. Okay, so try similar type of examples. We can see that we have to apply the quotient rule, but it is easier to rewrite them. Like see one example. Here you can already see, you can see that it is good, you can see to apply the quotient rule, but it is good to rewrite this problem like this. How? Just divide with x in both the terms. So you will get 3x square upon x plus 2 under root x upon x. So when you divide it, it will give 3x plus root x, 2 you cancel out, 2 to the power 2 into x to the power minus 1 by 2. So it is very easy to solve like this, except applying the quotient rule. So let us solve it. So differentiation of 3x plus 2 x to the power minus 1 by 2. So from the first function 3 will be out, the differentiation of x will be 1 plus 2 will be out, that is minus 1 by 2 x to the power minus 1 by 2 minus 1. So it will return 3, here 2 cancel out, minus 1 will be here, x to the power minus 3 by 2. So this is the answer. So see, it become very easy when we divided the f with g. Okay, so it is not necessary to apply all the time the quotient rule. So we have to deal with the situation. Okay, here are the some summary of formulas we have already read. That is, differentiation of constant term is 0. This is power rule. This is differentiation of e to the power x. How constant term gets out from the differentiation. Okay, and product rule and quotient rule. So you have to remember these forms. So here we stop our video. We will meet with you in another video with more questions and more things. Till then, if you like our video, please share and subscribe our channel Padhai Likhai with Saurabh. Till then, thank you. Bye bye.